It's great to be here, and we were one of the things I'm going to talk about a bunch of different things, but we were on the phone with a bunch of people from Hollywood today, and we're trying to, I don't know, maybe we call it infiltrate, like get into some of the kids' television shows with tech. Because we're never written in, none of us in this room are ever written in the characters, or if we are, we're like the Big Bang Theory people. And some of us are like that, but most of us might not be. Sometimes we are. And it's so fun to talk to you guys because there's such a divide in, there's like people who know how to do these magical things. They know how to write incredible things. How do we get the groups together? So it's kind of fun to be between the two. Is the sound okay, or is it a little funny? Okay. What I want to talk about is this idea I have, like I've been labeling it heroic engineering, which is just the stuff of what we get to work on, the wonder of it, but also the impact and the contribution and the service of it, and a little bit about talent and some of the trends that I'm seeing. I'm not a computer scientist, I'm a mechanical engineer, so I'm not going to dive into a technical talk, and the things that you might ask me about might be more about partnerships or strategy or those areas and projects, and less about sort of the deep tech area. But the thing we all know, and you guys know more than anybody, is I love this picture because it's a picture that one of the engineers hooked up to. They took the planet, sort of this globe model, hooked it up to our data centers. And so it's showing kind of Google search. And so each of the dots are representing a certain amount of searching. So red is in English. You see some Spanish coming down through into Latin America, South America, a little bit of a lighter color for Portuguese, some blue out in the islands with French. But just how networked we are. It's like amazing how networked we are. And how that changes everything in such a fundamental way, including our ability to help each other and collaborate and really have impact in the world. And this is an image of from the science fair. And I was a science fair kid. So that's how I ended up doing engineering, because I got to actually do things. Like all of us who come to tech, we get a chance when we're younger usually to actually do this stuff rather than just hear about it. And I did a lot of solar energy, and the set of information I had, because I would take the bus downtown because it had a bigger library, was like the shelf of books about this wide, on the subject that I was interested in. But when these guys come to the science fair, this is the finals with the 15 kids who've run from around the world. It's so awesome because they are really on the edge of the state of their art, even though they're 13, 14, 15, 16, 17 years old. And the reason is because of the web. They can really connect to the topic that they're incredibly passionate about, not only research the content of it and watch videos and just really be at the edge of the art, but they also can talk to people. They can actually email any researchers in universities, and many of them do, and start collaborating as if they're a scientist in the field, which they become at that age. And it's really quite a difference, and it's so impressive when you see the top of that stack, because what kids can do, what youth can do, what anyone can do is just totally different. This is an image from some people that I met in Herat, Afghanistan. And they're 80 miles from the Iran border. If you think about Afghanistan, more than 60% of the population is 20 years old or younger. And so this country needs to kind of make itself happen, in the next phases. And so I love these guys. They are so fast forward. They're jumping into entrepreneurship, and they founded 6 companies. This is a small tech incubator that DoD fixed up for them in one of the old hotels there. And they're going for it. And the computer scientists, I think, are the most networked people in the world. And you think about sort of how collaborative it is. What is open source? And I mean, if you look at the Google code base, probably people say out of 10 lines of code, maybe 3 or 4 are written from someone else, and we've cross-contributed, and just this way that people share. And really how networked are 16 million people right now. And it sort of, to me, is where all of collaborative work is going. This is an image that came out of, it's from Colombia. 450,000 people on one Facebook group generated a march of 12 million people against the FARC, local terrorist group. Just so impressive. Like you think about Arab Spring, it's so impressive to think how the adjacency of not only data and the network, but the adjacency of people's point of view is really changing. That these people agreed with each other. They didn't necessarily know it. They didn't act en masse until now they can know that their point of view is adjacent, they agree. One of the engineers in Bangalore, Google, created a thing called Mapmaker, which is kind of a Wikipedia idea for mapping. Only about 30% of the world has metadata, like street names and hospital locations and schools and stuff. And so you really need to crowdsource a lot of that. A lot of people, when you go to an emerging marketplace, you look up on the map and there's a line, and you're like, I know 1 million people live here. Where's the map? And so this is Lahore, Pakistan, people just drawing themselves, whether they were local or diaspora folks, onto the satellite imagery. You can see some of these animations up on YouTube. It's so cool to see, all of a sudden people appear. And this is the activity on that tool. Just really incredible participation. I was with Biz Stone recently, who's one of the Twitter founders, and he was talking about how one of his lessons out of Twitter is just this sharing. That, there's some bad actors, but generally most people are good. And most people really want to help each other. And they want to participate and be seen and be a part of the mix and help. And so it's interesting to watch that play out at scale, in Wikipedia, in Mapmaker, in these different tools, in Kiva, in Kickstarter. This is an old image of Khan Academy. Does everybody know Khan Academy? Saul Khan, yes, yeah, okay. So I keep this image just because it's astonishing, the density of things and things that he's taught. And it doesn't mean to me that Saul should teach every class in the world. But it's like a disruptive moment where one person can just bring it. And to me, it sort of illustrates that all world knowledge can be available to each other in some way, and we can share it. This is an image from our 3rd grade classroom. And I love the expression that Laura, the teacher there, has. In effort, there's joy. And I think Khan is the beginning of this idea of flipped classrooms, of the lectures, like teaching in a better way for the kids and helping the kids be much more project-based. Here, these kids are doing a science fair. And this teacher, her goal is that in addition to the core curriculum she has to teach them, that really they could learn that in effort, there's joy. That could be a big part of school, that you learn to participate and be seen. This is looks like sports, but it's actually First Robotics Nationals. What if class was like this? And this class really is like this. And these kids are learning so much and they're having fun. And it's much more like the worlds we inhabit, where it's deeply collaborative and hard and complicated. And we don't know the answers. And we figure it out. And we look it up. And we run around and make things happen. So my son was saying the expression could be first robotics and then the world. Like first learn how to do robotics. Practice makes permanent. And then come help us change the world and improve the world. So just the notion using the network of really finding those master teachers out there who are there. We all have been taught by them, and really getting them to a point where they could help all the students in the world. This is an image that I just had from another talk, but I stuck it back. I left it in there. It's a project I got to work on, which eventually flew on the shuttle. But I bring it in here because in the education area, I was just a freshman. And so I didn't know how to do all the things that were there. But I got to work in the machine shop and build a lot of this hardware, which was really great as a mechanical engineer to do fundamentally, like working in the shop with the core tools. But just thinking about how kids could get to be involved, like we all have, on really heroic, amazing projects, even if they're kind of in the get the coffee position, that junior position. Because really technology is apprentice, journeyman, master. And in school, you learn reading and you learn writing, but at a lot of schools still you just learn you're given science information, but not everybody in K-12 really gets science fair and labs and hands-on stuff, and so we don't learn to write tech. So figuring out how to make sure people can do that. This is a super cool project from Ethiopia that they have two villages that they're testing. They've brought tablets that have all the kinds of stuff that we would give our kids, Sesame Street and videos and language learning. No one in these villages can read. No one can read within 10 miles of these areas. And the experiment is, could they teach themselves? And if they could do that, how big an impact would that be for the 50 million kids who don't have teachers, as well as for how we think about learning and letting kids drive a little more with coach teachers, like if you had a teacher. So they do one intervention, and the guys here come every 2 weeks to swap out the SIM cards and see what the kids are doing. But they have one intervention where they teach one adult how to plug it into solar, but the rest of the time they just hand it to the kids and walk away. The kids use 50 apps within a week. And they're on their path to decoding, and they're about to read. So it's pretty exciting. It's been going for about a year and a half. It's sort of an extension of the One Laptop Per Child program. And I put the kids on this side who won the Google Science Fair. The 2 guys there last year were from Swaziland. So I think these kids will be these kids very soon if we can get this connection going. Another adjacency in data was surprising to me. I got to work on the beginning of book search. And so with all the different partners in publishing and libraries and scanning all the books to get that corpus of data available to us for search to make sure people could find things this way. This was a cool thing the New York Times did in a tool that we built called Ngrams, where you can look who thought that all the words that were ever written would be adjacent in the cloud. And so you can actually look at humanity in different ways. This is the use of the word women that the New York Times looked up from 1800 to 2000, and you see the word women doesn't really happen in books until the modern women's rights movement starts. So you could look up all, we can reflect back on ourselves and see, using computer science and data, that it is adjacent. This is a little bit dark. I don't know why it's showing so dark. This is some deforestation pictures. The Google Earth team took the Landsat satellite imagery that has been, so many governments, everybody's been watching the planet since the 80s, really. So we have this incredible data set that we could use to debug water resources, forestry, other things. And so this idea of the adjacency to help us with climate change. So I've been at Google for a long time, and I moved over to this team called Google X. And X is a little more hardware versus pure software. And the notion of it is this idea of moonshots. So how do you use technology to make the world radically better is our goal. And we have a lot of hype. I don't know, people sort of talk about X and Sergey and like this crazy thing, they're making space elevators. But really it's just, classic lab, classic skunkworks kind of place. Much more hardware than software. Self-driving car, Google Glass, Makani, some of these projects are there, the new contact lens idea. But really culturally trying to be very Wonka-like, Willy Wonka. We have stickers, they say, save the Oompa Loompas. Really, it should be a fun place to work where you're trying to make some extraordinarily cool things happen. And we center around people. So we find awesome people who have great ideas. We sometimes call it Peter or Petra Pan with PhDs, and then get infrastructure around them. Very much not focused on research. We're finding incredible researchers, but then getting in the service of shipping. So trying to get, the self-driving cars, for example, amazing research has gone on for a long time and then continues in autonomous vehicles. Really fun DARPA challenges have happened. So could we now that we kind of feel like we can do this, can we get on that moonshot to actually try to get these cars on the road, get them shipping? So that's what that's sort of about. So very much ideas, prototypes, the kind of design is the new MBA, people sometimes say. Just start making stuff. How long do you guys think, like the Glass, Google Glass, how long before they had the first prototype of that? Any guesses? 5 years?
About 3 months.
3 months. 3 months. An hour and a half. Right? So like really being like diligent about prototyping right away and play acting and improv. So if you have an idea and you think, oh my God, people would buy this, like have someone pretend they're the customer. They pretend they're your partner, and you try to sell against them. You'll discover stuff that you would find years later, right in that moment, just doing like acting improv. Or in this case, what they did, like ripping apart their phones and throwing some kind of plastic, thing and grabbing it and, just making it kind of work. Just take the same thing, open it up, tether it. You learn a lot by just prototyping fast. This idea of 10x versus 10%, but also this back to improv. When you're doing improv, you're not supposed to say no, because this stops the flow, right? So we thought when you're brainstorming, why don't you have a rule, 2/3 yes and. So somebody's just proposed something. How are you going to help them with distribution, with money, with new tech, partners? What could you add to this? And then, yes, we all need critique. So 1/3 of the time or less, some critique, yes, but. So using those as sort of fundamental culture philosophies. And this idea of moonshots. So some kind of huge problem in the world or opportunity, some technology that might sound like science fiction, but just might apply in a way to scale it. So like the self-driving car, or even the moonshot itself, like we wanted to go to the moon. In Kennedy's speech, he's like, we're going to have to invent new metal alloys, use guidance missile, like all these things there, and then get us there. Self-driving cars, literally billions of people wasting time in traffic, lives lost, people texting, fuel, really a problem worth solving. And then from breakthrough technologies, you've got mapping, guidance, robotics, sensors, to a point where you just might be able to let the car drive itself in the current system, not needing new special lanes. Sort of in the moonshot itself, one of the things that I think is interesting is that it's like we're not unique to this moonshot idea. It's been going on for a long time, and this is Katherine Johnson. She's an African-American woman, 96 years old, who actually calculated the trajectories for Alan Shepard, John Glenn, and the Apollo mission. Or one of my favorite moonshot pioneers, Tesla. I'm from Buffalo. So his demo was to use Niagara Falls to light Buffalo, to show modern electrification in AC. Or George Washington Carver, incredible moonshot pioneer who, when he was from the middle of the U.S. in Iowa, Missouri, but he went to Tuskegee, Alabama to join the faculty of Tuskegee with Booker T. Washington. And when he rode on the train, he saw the incredible malnutrition that was going on in the U.S. and the monocrop culture of the U.S. and went into the lab with a moonshot idea to figure out crop rotation and then deploy that using the Jessup wagons and stuff. Or this incredibly heroic engineering moonshot. Do you guys know Bletchley Park? Yes, most of you guys know it. So I don't know how many people know, but more than half of the Bletchley team were women. And Turing was there, he was gay. So to me, there's not only this heroic engineering, but also one of the best diversity stories in history is here, because you've got the Nazis on one side who've decided that literally like a certain type of person is the best, and they're killing people who are not that person. And then on the other side, you've got Churchill throws together this sort of Steve Jobs commercial of the misfits and the crazies, like these wild, the Polish people got the initial insight, and just this really great band of folks who just got it done and started much of modern computing, as you know, and they're credited with saving 11 million lives and shortening the war by 2 years. Just an incredible story, and it's worth visiting Bletchley if you're in London. It's a 45-minute train ride out of London, and the station's right there. So what we've been doing in X, the thing that I've been a little more involved in is both some of the early stage projects and rapid eval, less of the scaled one. But also my friend Astor and I started this thing called Solve for X, which is a way to help moonshot pioneers who are anywhere in the world, not necessarily in our labs, do their thing, get a platform, be heard, almost like a subset of TED Talks that are moonshot proposals. So we've launched that, and we pay a lot of attention to diversity there too, just finding people, men and women from all over the world, different parts of the world, all different ages and different races, backgrounds, and hear from them. Also been working a bunch on something called Women Techmakers. If there's 16 million programmers in the world, there's 2 to 3 million women programmers in the world, but we don't see them as much as we should. So the first place we worked was on Google I/O, where we have 1 million people on live stream. So just as a company, what could we do responsibly to make sure that you can see the top talent out there on our stages? And we actually got a tweet off the New York Times last year, 3 women on stage at Google I/O, tech company first, ? And I wondered in some ways, like, if you thought about all the conferences, our conference and Microsoft and Oracle and Facebook and everybody, we don't have many women on stage at that level, and we need to make sure people are up there because people are building the products. You need to see them. So we've created community and visibility there, and part of the Google developer groups, which meet all around the world, we've added a layer of some women Techmakers groups there. So 10,000 technical women met during Women's History Month, just increasing the visibility as like a fundamental goal. One thing that's interesting about this unconscious bias work that we've been doing, where we're training the whole company, we never realized that for the first 7 years of Google Doodles, we never celebrated a woman's birthday. And we had no idea. Unconscious bias just lives in all of us. We didn't generate it, but we do need to debug it. And so getting us there now, we're at 50-50. You may be noticing that in the birthday doodle celebrations. We're very similar to the industry standards, like 15%. So I don't think we're unique in that. But I think what's nice this year, and I think to your point, it's a serious problem of our industry. I was actually just with someone in Hollywood, a woman who wrote The Devil Wears Prada and stuff, and she said they have the same issue, 15% women writers in Hollywood. In fact, Gina Davis, who's done, and I'll talk a little bit more about this, but has done a study on children's television. And it's 3-to-1 boys or women to girls. I have a slide up a little about that on kids' TV. And you see things like the film Finding Nemo. How many women in the ocean in the film Nemo? Like the whole ocean? One. Like, why are we doing that? And it turns out that computer science is actually 15-to-1 in kids' TV. And it's 5-to-1 in STEAM careers. And so that's why we're talking to Hollywood. Like, they went to school where we made them terrified of math and science or bored by it. And so they're not writing it because they're not familiar. They don't want to be wrong. Or they don't know, it's not in their world because we're divided from them. So trying to look for signal to noise, key things that we can do to help. And they have to do with, like, in the K-12 area, it's pretty clear that the sooner you have an actual experience of making things yourself, the more likely you are to understand why you would, why are we doing this, that it's fun, build your confidence by doing it. That helps. That visibility and role models help. That putting it in the curriculum helps. So there's a bunch of interventions that are becoming, obvious or, rising to the cream in K-12. At the college level, I think Harvey Mudd is the furthest ahead. Harvey Mudd's at 45% women in computer science. I like their fundamental research, though, because they went and asked high school girls why they weren't doing this, and they had 3 answers. One was, it's super boring and has no impact. Why would I do that? Which is interesting because we can see the impact, but they couldn't. So that was a PR series problem. Second, they're like, I'm not going to be good at it. Third was, I don't want to hang out with those people. So we also have just done some similar research, the same thing that we are finding. What are the interventions? 70% of high school computer science teachers think that boys are better than girls, despite overwhelming evidence. So there's a lot of work in these areas to do. So those 3 are helping kids understand that the stuff they love is made with code, and that the things that have impact, why we do that. So they changed their curriculum at Mudd, which really helped. Instead of kind of giving kids, here's the homework problem, can you figure out the fractal, blah, 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 like, fine, that might be interesting to somebody who already knows what that is. But if you don't, maybe we could say, hey, we have to get some drugs delivered to this set of people in a certain order, and so we need a sort routine. Context really mattered, and they changed their homework and the way that they were doing that. They got the kids quickly to the field. So they teach Python, they get you right into an internship, they get you to the Grace Hopper Conference, they get you to see other people because of the stereotypes from television and from your high school make you think that you don't belong in the field. A lot of the work in recruiting is, again, visibility. People are hidden, they're there. There's lots of people, there's lots of women and minorities already in our field. They're just hidden from us. I asked the computer science dean for Spelman, where are your kids going? Like, where are the African-American women computer science undergrads going? And she doesn't have tons of them, but she has some of them. Where are they going? They're going to the banks. They're going to the accounting firms, which is fine, but I like some of them in Google. I'd like some of them in Microsoft. I'd like some of them. So how do we go get that pipeline coming? And I said, why are they doing that? The alumni are going back to recruit them. So it's sort of go and find, it's a very, almost like scouting, go find these people and get them. A lot of the schools, like the university, are doing a great job now. Like I said, I'm on the MIT board. We're about 50-50 men and women in undergrad and about 27% underrepresented minorities. So the kids are there, so go get them into your companies. And part of that, back to this bias, is become educated about your biases. Like, one of the great data points on this is a simple one. If there's 10 qualifications for a job, on average, men will apply if they have 3, and women will apply if they have 7. And so if you're a manager, you just have to know that. You just have to know that that's happening in front of you. So a group of people have their hands up, or a group of people don't. You may choose from any of them, but know what's happening, know the data in front of you. And so you might, say, if you're managing a young woman, you might know the stat, and you might say, okay, you're ready, push them. If you're ready for this. If you think they're ready, tell them. They might not have noticed. They think they have to train some more, right? So this kind of debugging is important, if that helps. So I think that one of the biggest things you can do actually I always divide the problem into K-12, university, and college, and professional, because there's different interventions you do at different points. With K-12, it's about getting the kids to try it, right, and feel comfortable and keep their confidence. With university, it's about debugging and getting them in and staying. And with our levels, it's about getting through, opening up the innovation space to try to solve some of these incredibly difficult problems that we've inherited through the weight of history. So, and part of it also is convincing people in the companies that it's important, that it matters, that it's relevant for their products. Most people in tech are not yet convinced that there's a problem. This is when I talked about at the beginning, the network. When it spins around, look at Africa. These slides are a little dark, so you can't see as well, but look at Africa. Look at Europe. There's tons of traffic in Europe. It's not time of day, and there's no traffic to speak of in Africa. 900 million talented people, basically totally offline. So to me, it's astonishing. This is 2005. And if you guys can see, there's like a very light pink cable here. And on this side, this pink means planned. I don't know what the UN and the World Bank and all these people have been doing, but like a continent without a cable would mean that these people can't really participate. It's like, seems almost criminal to me. The good news is it looks like this now. And so we're seeing, here we are in San Francisco with lots of startups and share spaces and stuff. This is iHub Nairobi. You might as well be here. Like we're seeing the emergence, Nigeria, Ghana, Senegal. These folks are coming in to join us. And it's, I think, one of the most exciting things that's happening in the world is as the talent of the world, the rest of the talent of the world joins the global conversation for innovation. This is a picture that from some of the Loon work. Shows you who's online so far. So gray is all the talent that still is going to join us. And that's where Project Loon came from, which is some of my colleagues launched this idea to put balloons. There's a video up here. It's so dark. So here's the planes. So it's like twice as high as the planes. And the balloons talk to each other, and they talk down to the ground to the different carriers to try to see could we solve in this way. And right now there's tests over New Zealand. So just fun, crazy moonshot that just might work. The last network area I wanted to talk about, which kind of speaks to the conversation we've been happening, which is, this is Silk Road, and it's a picture down below of the Erie Canal. I'm from Buffalo, so I have to shout out to the Erie Canal. But, networks are so important for commerce and economy and that kind of stuff. And the Erie Canal itself dropped the grain price for the US by a factor of 10 to get goods out of the middle to help with development, but also get goods in, and really was very important in the development of the US. But it's also the place where some of the largest conversations, the most volume of conversations for change happened around abolition and women's rights. I don't know if you guys know Seneca Falls. President Obama in his State of the Union mentioned Seneca Falls, Selma, and Stonewall, talking about civil rights evolution. Seneca Falls is right on the canal, and it's where the first Women's Rights Convention happened. Most people don't know about the Declaration of Sentiments, but it's a document like the Emancipation Proclamation. It's a very fundamental document in the area of women's rights. Elizabeth Cady Stanton wrote it. And so, from her down there in the corner on into, Catherine Switzer, who ran the Boston Marathon in the 70s, and the race director tried to rip her numbers off, like amazing, crazy stories of people trying to earn their rights. We're getting to a point where more people are coming to the table, and I think the internet and the network is having a lot to do with that. I've been doing a lot of work on the resurrection of the lost history of technical women and minorities, and we talked a little bit about Katherine Johnson and the NASA team. Most people don't know that there was a parallel corps of astronauts who were women through the whole programs through the 60s. No one ever made suits for them, so they never got to fly, but they would be equal or sometimes better on certain measures. Sort of a sad history. Do you guys recognize anyone else on here? Yeah, Hedy Lamarr, Fundamental Inventions in Mobile, also a Hollywood actress. Who else I heard? Grace, yeah. I mean, Grace, it's amazing that people don't know about Grace, Turing level. To think of the idea of computer languages and compilers and subroutines, in addition to coining the phrase bug, but like subroutines, they're kind of useful. So she's amazing. Or Ada Lovelace. Do you guys know Ada Lovelace? People are starting to know her more. She was Lord Byron's poet math daughter, and her mom wanted to protect her from her poet dad, so she taught her all this math. And she was friends with Babbage, who did the first mechanical computers. And so she's the one who wrote, the first person to ever write the idea of programmability of things and how algorithms could weave like the Jacardian loom, and beautiful poetic language. And Walter Isaacson sold 2 books when he sold the Steve Jobs book. He sold a second book about the beginning of the digital age that he's working on, and it starts with Ada. He was just in the Bodleian Library reading the Byron family collection. He's like, this is all true. It's an amazing story. So she's incredible. And then I mentioned the Bletchley women and ENIAC. Do you guys know the ENIAC, University of Pennsylvania? A friend of mine, there's a film launching on Saturday called The Computers. It's a 20-minute film, part of a new series. My friend saw these photos. She was a history student at Harvard and a computer science minor. She saw the photos and she's like, who are these women? And everyone said, well, they're modeling. They're modeling the ENIAC. And she's like, oh, they don't look like they're modeling. And so she pursued it. She called UPenn. They were having a reunion. Like, they're incredibly proud of the ENIAC. They should be. And they're like, she said, are the women coming? And they said, what women? And it turns out that the people who programmed the ENIAC were these 6 women. They were called computers. They were part of World War II, Rosie the mathematician. And there were 100 women at UPenn calculating trajectories for the guns, awesome differential equation work. And Eckert and Mockley went upstairs and got 6 of them, asked them to come down and figure out something to do on this machine. And they got the wiring diagrams, and they figured out how to program. So they're the first modern programmers in history, so there's a film about them. And so luckily, my friend found these photos before they died. None of them were alive anymore. And interviewed 4 of the 6 of them. And so the film has them, and it's amazing history that's being resurrected and really exciting. And I think it's really important to know this history because even though some of these different groups are a minority, they've always been here at an elite level. It's just they got written out. This is a good example of that. I was lucky to work at a company called General Magic, which is kind of like the Fairchild of mobile. A lot of the roots for Android and iPhone come from there. I can tell you more about that. But many of the people who wrote the Mac were the founders of the company. And so this is the original Mac team from Rolling Stone. Lots of cool photos of them. And what you'll notice, like in the pyramid, there's 7 men and 4 women. Joanna Hoffman over here is the product manager of the Mac. Susan Kerr and Bill Atkinson are really the graphics team. Bill wrote the back-end quick draw, amazing computer scientist. Susan is incredible human-computer interaction artist, all the graphics that you saw on the Mac. What's interesting is in Hollywood wrote the movie Jobs, they sort of have the stereotypes of our industry. So every man in this photos has a speaking role in the Macintosh section of that movie, and every woman in this photo is not in the movie. So we've got to work on it. I talked about Gina Davis already and changing children's television. And why it matters is kind of summed up in this interesting This Media Matters story. Nichelle Nichols, who played Lieutenant Uhura, was once at dinner. And someone tapped her at this fancy dinner, tapped her and said, someone would like to meet you. She stands up and there's Martin Luther King Jr. And he was really happy to meet her. She said, well, honestly, like, I was thinking about quitting Star Trek, and they keep cutting my lines, whatever. He's like, you can't quit. He's like, you do more by being into that American living room every week, being in the team, on the flight deck, included, heard, than I can do in all my speeches. Now, she didn't agree with him, but it's an amazing point of view to think about how important media and imagery really are and thinking about that. So back to kind of just Solve for X and the talented people in the world and all of you guys, we have magical skills that we can do extraordinary things. And so doing heroic engineering is important.